Okay, probability wave functions are fundamental to quantum mechanics, describing the quantum state of particle or state system. Radial distribution wave function, angular wave function. Radial distribution wave function, let us take a sphere having the radius r. It is divided into a number of concentric have one center spherical shell having thickness dr and the volume. Such concentric spherical shell is given by 4 pi r squared dr. Radial distribution curves obtained by the 4 pi r square dr psi square versus r is called radial distribution curves, where 4 pi r square psi square dr is the radial distribution function, psi square radial probability, also written as r square in terms of radial distance from the nucleus, r distance from the nucleus. Radial distribution curve for 1s, 2s, 2p, 3s, 3p, 3d are plotted as below is flowing. If n is principal quantum number, L is azimuthal quantum number, L equals 0 to n minus 1 for n 3, L equals 0 to n 3 minus 1, 0 to 2, 0, 1 to SPD. We know that number of peaks in the curves n minus L for 3s of cell n equal to 3, L equal to 0. So 3 minus 0, 1, sorry, 3 minus 0, 3. For 3p, n minus 1, L equal to 1. So 2 peaks. For 3, n equal to 3, L equal to 2, but 3 minus 1, 1 peaks. This is the 3p orbital, 3s orbital, 3d orbitals. For 4f, number of peaks n minus L, n equal to 4. For azimuthal quantum number L for f cell 3, so 4 minus 3, 1. Similarly, 5d number of peaks equal to n minus L, n equal to 5. The for azimuthal quantum number 2, 5 minus 2, 3. For 4p, n equal to n minus L, n equal to 3, 3 minus 1. So for 4p, number 3 minus 1. So 4p for 4p, n equal to 4. 4 minus 1 equal to 3. For 2p, n minus L, 2 minus 1, 1 peaks. Feature of distribution curve, the probability of finding the electron is 0 at the nucleus are equal to 0. The most probable distance of the finding electrons increases markedly as the principal quantum number n increases. The most probable distance probable R for the probability of finding electron decreases slightly as the azimuthal quantum number L increases and n remains constant. The number of peaks present in the radial distribution curves n is np and d orbital equal to 1 is 2p and 3d. The penetration power of the SPD and F orbitals decreases in the order ns, np, nd, and f. So the s orbital has the highest penetration power, that is lies in the nearest to the nucleus than other orbitals. The region around the nucleus at the which probability of finding an electron is 0 is called node. The number of nodes present in the radial distribution curves are equal to n-1, n-2, n-3 respectively. Angular wave function, according to the Bohr's theory, in hydrogen atom, electron always revolves around the nucleus at distance 0.5 to 9 Armstrong. But according to the wave mechanical approach, an electron can fall anywhere around the nucleus. However, the maximum probability of lies at the distance 0.5 to 9 Armstrong. This distance is called radius of the maximum probability